My name is Greg Newman. I'm a research scientist at the Natural Resource Ecology Lab at Colorado State University, and bring you greetings from Castlegar, Canada, BC. Beautiful place. We had the great fortune of being invited to talk at the New Technologies in the Field workshop here at Selkirk College in Castlegar. And yeah, it was great meeting people so far. A lot of discussion already about the benefits and drawbacks and challenges associated with collecting digital data in the field, ecological data, using digital technologies in the field. My background is a plant ecologist originally, and I work at the Natural Resource Ecology Lab at Colorado State University in a variety of capacities, all dealing with community-based monitoring, citizen science, and ecological informatics. We've got a variety of projects started that focus on citizen science, and I'm the director of citsci.org, which is a web-based platform supporting bottom-up citizen-based monitoring programs. Our experiences to date have been a lot of learning and trials and tribulations from the monitoring groups involved, and we like to think about a few things that are important and overriding principles to what we do, and that's learn from the masses and before teaching them. And the volunteer monitoring programs we work with teach us what and drive the tools we're trying to build in support of their efforts. One of the things we've really focused on is making it really easy to do all of the tasks associated with citizen science and community-based monitoring. Those tasks can be simple. You might real simplistically look at, well, you could create a project, ask a question, create a data sheet, and get out there and start collecting data, and then you might analyze data, visualize data, and then get some feedback about how it went throughout the field season. However, that might sound simple, but in reality, it's a lot bigger and harder than that. And so what we have is, when you're simply asking a question, well, what is your research question? What are your protocols you're going to use to answer that question? What partner scientists are you going to work with as a nonprofit organization, maybe at a nature reserve, to get some scientific advice to guide you in defining your methodology, your protocol? And then when you're creating a data sheet, are those numbers floating point numbers, or are they integers or strings? And then when you're creating that data sheet, is other people measuring similar things, and might you adopt those same protocols to make integration of data easier after your field season? And when you're training your volunteers, heck, you got to buy them burritos. You got to have something to eat. You got to train those volunteers, and you got to have good protocols to follow and good training materials for them to follow, so you can ensure high-quality data from citizen-based monitoring programs. Likewise, we have a variety of professional monitoring organizations, like consulting companies like Summit Environmental Consultants here in BC, that are here talking about the same thing, using digital technology in the field. And so whether you're a volunteer monitoring program or whether you're a professional environmental consulting company, the same principles hold true, and that's really thinking about the breadth of activities that need to be done, and can digital technologies help all those activities, and which appropriate technology is appropriate for which task. So with that, we're excited to hear more talks throughout the day and learn about how to use appropriately digital technology in the field to improve data quality, efficiency, and interoperability. So I'm excited to be here, and looking forward to learning from the group. How many people have one of these devices? So those without your hands up, do you feel out of the loop a little bit? A little bit concerned about, well, maybe I'm not up to speed. How many people have the old school field notebook? All right. So it hasn't gone out of favor entirely, I guess, apparently. So the pen and pencil still do work. How about one of these gadgets, which we all turned off for the sake of, so fewer but numbers of smartphones out there as well. Looks like iPads win by nomination here, it looks like. But, well, I appreciate the invitation to come talk with you guys today. Is there like a clicker guy that, oh, just use the arrows? Just use the arrows. That'll work. Yeah, so I appreciate the opportunity to come to this beautiful place. I'm a mountain lover. A lot of colleagues of mine work at the Mountain Studies Institute, which I think is much akin to CMI in its focus. It's a mountain ecology research laboratory, kind of has that focus. So I love to ski, How many people also are skiers in the crowd? Fantastic. So anyway, this is kind of home for me, and it's good to be up here. But today I think we're all going to be, well, today and tomorrow over the course of the workshop, we're going to be working on kind of writing a story. Collaboratively, all of us are going to write this story about new ways of using technology in the field, collecting ecological data. And it's going to be our story, and just like our data tell a story, we will be able to tell a story through our discussions with each other and through our interactions and our workshops and our hands-on activities tomorrow. So I invite each and every one of you to kind of tell the story with us together as a team. And that's what citizen science is about. It's about getting people together to tell the story of their community, to tell the story of the trends they're tracking, be it pika populations or stream quality or invasive plant invasions or rare endemic plants populations hopefully improving or declining, whatever's happening. We together in citizen science arenas are telling stories, and so I think we're doing that same thing over the next couple of days. So what is this story about tracking technology in the field all about? I want to start with a couple basic tenets that I like to think of about citizen science and information management in general. And those tenets include this quote: "Tell me and I'll forget, show me and I may remember, involve me and I'll understand." And I think tomorrow is all about involving us in this process so we can understand how to improve our data collection in the field. Second tenet, learn from the masses and then teach them. I'll tell a quick story about students at the University of Colorado, our other university in Colorado. I'm, of course, Colorado State University. I'm a proud Ram, but those Buffaloes down there are also in the state. So they set out to say, okay, we don't want to put our sidewalks out. We're going to let the students wander around from building to building first and see where they go. And then, once they followed the trails, they said, okay, well, this is where the students want to walk, now we'll put the pavement down. And so I think that kind of speaks to this whole learn from the masses, sometimes they know best, and then teach them. And then finally, third tenet I want to keep in mind throughout the day is the art of teaching, or the art of doing research, is the art of assisting discovery. And so I think what we can be all thinking about is how can our data and our data sets tell stories that can assist discovery? What patterns might emerge in the data sets we're collecting efficiently with these gadgets that we'll talk about throughout the day. So I want to kind of introduce citizen science and community-based monitoring and public participation in scientific research, whatever you want to call it. And I want to introduce it in light of that it's not just data collection. There's a zillion activities that are involved in the citizen-based monitoring project. How many people are like nonprofit? How about agency, provincial government? So, and how about research, academic? So we got a smorgasbord of backgrounds, and that's exactly what citizen science is all about, is bringing together those different sectors and stakeholders to accomplish monitoring goals. But it's not, as you all know, running a project or monitoring project, it's not really about collecting data only. You got people involved, you know? You've got odd personalities like myself. And so, you know, you got to figure out how to talk with each other, work with each other as a team, and so there's more than just collecting data that this technology might be able to help us with. There's many activities, many technologies, and many solutions. So what we've got is, well, what do we need to do? I mean, when we're monitoring the environment, what does that involve? And it's not just data collection. There's a lot of factors that are involved. So I like to think of it as this simple model of, well, we're going to create a project. We're going to go monitor pikas, or we're going to monitor black bears, or badgers, or invasive plants, or stream quality, whatever it might be. And we're going to manage our members. We're going to have trained volunteers that might help us. We might have trained technical staff if we're in the agency world. We might have data sheets, you know, that we got to collect, we got to fill out, we got to design, we kind of got to create and build our data sheets, follow protocols. Collect data, of course, which we're going to talk a lot about and maybe do tomorrow. Analyze data, interpret data, and share results, and maybe get some feedback along the way. Looks simple, right? Simple couple steps, no big deal. Piece of cake.
Unfortunately, the reality is not so simple. When we're collecting data, we're managing data, we have to ask questions, we have to formulate research questions, create logic models, maybe market the project, advertise to constituents, manage roles, identify protocols. Good grief, we got to define our methodology, we have to partner with scientists, develop trainings, buy burritos, right? We got to all eat. We got to, we got to feed the volunteers, feed the technicians, train the members, order supplies, maybe pick your favorite device, be it a Yuma, or be it a Trimble, be it a what, this, that. You got to figure this all out. You got to perform quality assurance, quality control. You got to run statistics. Which statistic do I use? Is it an F statistic, a T statistic? What's going on? Create graphs, summarize the data, visualize the data, create maps, write metadata. Anybody know metadata, right? How many people take the time to actually document a data set? And so we had all these iPads, tons of hands, lots of iPads, but no hands coming up with metadata, right? It takes too much time. So, and then we got to get feedback from the volunteers or the technicians or the professional staff that we're working with, or even students. How did it work? This summer's effort, we wanted to measure bats. How did it work? Did it work? Did it give us the information we need, or did it not? So clearly, it's not just those simple tasks. It's a lot more. So in addition to that, we've got Brendan here measuring foxes, maybe badgers, whatever. We've got Ian over there measuring streams, and we've got a lot of other people measuring pikas in the high country, like we do in the Front Range of Colorado. But all of these efforts tend to be silos. They tend to be little organizations going about their business, and maybe they want to streamline their data collection. But how might this work, and can we envision a future that maybe is more connected? So I like to think of this as, oh, thanks. Fantastic. Perfect. So I like to think of this as like a group out of Wisconsin called Water Action Volunteers. And they're paddling for a purpose, they say. And so they're measuring like Eurasian water milfoil in the streams of Wisconsin. And then maybe we have bioblitzes going on. I think we're going to do one of those tomorrow with iNaturalist, I believe. And then the Christmas bird count. Everybody heard of the Christmas bird count. So we've got all kinds of these citizen science projects. The City of Fort Collins Natural Areas Program, where I'm from, it has an amphibian monitoring project. And some of these projects are short-term in nature. They just happen like a BioBlitz today and we're done. Other projects have been happening for centuries, Some of the first naturalists, Darwin has been making observations for years. Many. This is not new. Citizen science is not new, and Audubon has been doing monitoring. So anyway, they might be doing this for a long time. And the spatial scale might happen at a little natural area, like in the city of Fort Collins, and maybe they're going to monitor amphibians, and it's real local. Or maybe we've got people, for example, like the Christmas bird count, who on Christmas Day all go out across the entire country and measure things, measure birds that one day. So it's a very national or global scale. So these projects operate at small, local, large spatial, small spatial scales, short time, long time, and they tend to be silos, and they collect their data and they go about their business. But what might it look like if we start interacting with each other and saying, hey, I too am measuring pika, like in the Columbia River Basin. The Oregon Zoo called me up and said, well, we want to measure pikas too. And we've been measuring them through the Denver Zoo for many years, 3 years, and we said, well, maybe we should use the same protocol. Maybe we should measure things in the same way. So I think what I'm proposing here is that we all talk to each other. That sounds novel, but I think it's kind of important. And so the plant people should be talking to the bird people, should be talking to the stream people, and the data set should talk to each other as well. So a lot of these apps use web services to send data to servers, and these data silos might talk to each other in innovative ways, and that might help us lead to serendipitous discovery. So what I'm proposing is we move from scenario A, where we're at, to scenario B, where we're a little bit more connected. And if there's any questions, by all means, just show up a hand, interrupt me if you have questions or thoughts as they come to mind. So now I kind of described a lot of citizen science projects, and maybe they're operating at a particular scale, and I've talked about all the activities that they might be involved with. But how do participants in citizen science projects and community-based monitoring projects actually do participate? Well, there's all kinds of different ways to phrase this, but there's and I like to think of them as chocolate, vanilla, and strawberry. I mean, you could call it one thing, you could call it another, and people have been discussing this in many times, but one way, back in '93, people were talking about this as what they call the citizen participation ladder. And so people talk about, hey, the public should know what's going on with their environmental resources. They should be informed. They should have a right to object to any decision being made. They should be involved in defining the interests, actors, and determining the agenda, the research agenda. So this might be a little bit more level of involvement. And then furthermore, they might be involved in assessing risk, recommending solutions, and making final decisions. So this was kind of some initial thinking on what it looks like with the public participating in decision making. More recently, Rick Bonney and others at the Cornell Lab of Ornithology in Ithaca, New York, came up with this model where they talked about contributory projects where you have your volunteers or your actors collecting data, and that's their role. They collect data. A collaborative model is more where they're more involved collaboratively with scientists and natural resources managers to collaboratively make decisions. And then co-created projects are those that actually are bottom-up. They're really kind of grassroots efforts that community themselves created a project on their own in conjunction with scientists. So there's a growing field, at least we're working on building the field of public participation in scientific research or citizen science. Community-based monitoring, whichever you call it, again, chocolate, vanilla, or strawberry, it really doesn't matter, but there's these different models and these different levels of engagement. So you want to think about, are you just building an app for the contributory model, and are you just creating something that's going to help facilitate data collection, or are you doing more than that? So another way of looking at this is Finn Danielson's work. I don't know if anybody's read his work, but I recommend it highly. Really good friend of mine. He's in the Netherlands, I believe, but he created a website called Monitoring Matters, and he's a big advocate of monitoring and community-based monitoring, and he even recently wrote a paper that says the time to decision making when you're doing it collaboratively in a citizen science framework is like 1/10 of that in the academic world, because we have to go publish, we have to vet all this, get peer review, and get it out there, but the community themselves, if they're doing the monitoring themselves, can get it out there right away. So anyway, he came up with this concept where there's category 1 monitoring, which is externally driven, professionally executed monitoring, and then category 2 being externally driven with local data collectors. We might be doing that here tomorrow, figuring out how to collect that data. Category 3, collaborative monitoring with external data interpretation, and then category 4, collaborative monitoring with local data interpretation, and finally autonomous local monitoring. So regardless of whether you're at Cornell and you're calling this contributory, collaborative, or co-created, or whether you're Finn and you're talking about categories 1 through 5, I think it's just important to be aware of these different levels of participation. There's also different approaches to participation. We work a lot with crowdsourcing efforts. We also work with local traditional ecological knowledge projects, and we also work with collaborative conservation efforts. Robin Reed at Colorado State University has created the Center for Collaborative Conservation to really focus on bringing these people together to collaboratively do natural resource management. So what the heck is crowdsourcing? Ian, any idea what it is? I'm going to walk over here.
It's kind of the wisdom of the crowd, tapping into the wisdom.
Perfect. The wisdom of the crowd. I think that's what we've got here, is we've got a lot of wisdom in this room, so we want to crowdsource what tools are the best ones to use. So we ourselves are going to do a little bit of crowdsourcing over the next 2 days. But simply defined, it's the process of outsourcing tasks to a distributed group of people. that's been done many years now in a variety of disciplines, not so much in the ecological sciences, but more in astronomy. But there was a book recently written called Reinventing Discovery by Michael Nielsen, and the author talks about how the process and the paradigm of science is fundamentally changing, how we make discoveries. And it's changing because people are putting things out there in the open, in an open data standard kind of format, and things are discoverable. They're accessible, and they can be mined. And when you do data mining, you can do meta-analyses, and you can find serendipitous patterns emerging from these data. So the very nature of science is changing based on the technologies we're seeing and we'll be talking about over the next 2 days. But what makes these types of crowdsourcing projects successful? One is that they have a shared praxis or a shared goal. There's a million people out there targeting or doing a task, but they're all doing it for the same reason. And these efforts can amplify collective intelligence. So we might have a plumber, we might have an electrician, and we might have an artist in the room. I like to oil paint, so I point to myself on the artist. But that collective expertise can bring more skills to bear to the problem at hand. And then finally, we can restructure expert attention. So taxonomically, you might have a botanist in the crowd that really knows the taxonomy of plants, but then someone else might know, hydrology, and so we could restructure that attention to the domains that it's important to address. So anyway, I highly recommend this book. It's a very, very good read, Reinventing Discovery. Check it out. But crowdsourcing, it's been done now for, 10 years or so as a technique. But the Zooniverse created Galaxy Zoo, where a bunch of people log on to these little laptops here, and they classify galaxies that would take pictures of galaxies that were taken by the Hubble telescope. And so they say, is it spiral galaxy, is it a elliptical galaxy, or whatever. And they have actually discovered entirely new galaxies doing this approach. So another approach is they can use crowdsourcing to unravel protein structure. The Foldit application, where you can log in and it's a puzzle. You can try to figure out these proteins for science. And of course, make species observations. How many people are familiar with iNaturalist? I think we're going to have a demonstration tomorrow about this platform. So clearly, we can crowdsource species observations as well. And so another approach is this local ecological knowledge approach, called many things. Traditional ecological knowledge, indigenous knowledge, and we're working in Ethiopia and East Africa to do this type of approach. It's kind of a crowdsourcing approach, but to capture that local ecological knowledge that might be lost as cultures change and evolve. So that's another kind of approach to citizen science. And approach I'm more familiar with is collaborative conservation approach. And we really work on kind of the supporting the bottom-up projects, the small grassroots projects that may not have server administration, they might not have developers, programmers with PHP and Ruby on Rails and JavaScript and all these things that we're going to talk about, expertise. And so there may be a nature center and there may be a staff of one, and that's all they got. So they don't have programmers, they don't have servers, and so they're like, well, what do I do? So, and they still want volunteer monitoring to happen, or collaborative conservation to happen. So what we did in work that I've been involved with over the last 5 years, I think, is we built a support platform for the bottom-up projects that needed those resources. So we're going to talk about Reporter Weed, I think, and we're going to talk about various apps. There's a water quality map app that I downloaded on my iPad at Northern Kentucky University. That's really cool. I can show it to you guys. But we're going to talk about all these different apps, and they might do different things. There's an app for bats, and there's an app for streams, and there's an app for weeds. But what I was thinking about about 5 years ago was, boy, it would be really troublesome for these small organizations to build an app for each thing they need an app for. So what we attempted to do is build a support platform whereby project managers from these nature centers could create their own monitoring project, get volunteers to get started monitoring data and create their own data sheets online, and then have them use that in the field to efficiently collect data. and bring that all together into this platform. So we built sitsci.org, of which I'm the director now, and I guess our team kind of put together this platform, and it's up to about 66 projects now, and I won't go into it in too much depth, but because there's more I want to talk about that kind of frames the workshop. But sitsci.org is a place where people can create projects, and we just 2 days ago there was an observation in Wolf Creek, or I think they have a certain naming convention in Pennsylvania, and there was a Trout Unlimited project monitoring stream pH, connectivity, water flow, and temperature in Pennsylvania, and they wanted to monitor stream health given recent fracking operations in the region. So they've been going at it, and they've now submitted some 1,500 observations in the matter of a month alone. So that is some serious monitoring, really quick. And every day I log in and there's a new observation. I'm sure there's one today. So anyway, what is all this thing? What is sitsci.org? It's a place where people can create projects. They can log in and request to become a project coordinator, and then we work with the coordinators only. The coordinators then work with their project members. So it's like a train-the-trainer model. So people can log in, request to create their own monitoring project. We've got piker monitoring, we've got stream monitoring, we've got bat monitoring, whatever. And so we approve them, we talk to them and say, okay, this is what you're about to embark on. It's an adventure, but we're here to help. And so they get started, and they maybe conduct a training at their library or local community center, and then they themselves approve members online. So they know who has permission and has been trained in the protocol, and therefore they can vet the quality of the data that way. They can customize their project. They can manage their members. They can email their members and say, don't forget your GPS unit, or your waders, or your binoculars. And they can change the order of these tabs. They can say, hey, we're in field data collection mode, so we're going to make the submit data tab first, or the observations, and then maybe at the end of the field season we might say maybe we're going to offer a survey for them, the volunteers, to take to give us feedback. So you might make the feedback tab first in the list. So you can manage these tabs by moving them up, moving them down, and you can refocus attention appropriately. You can document your research questions and just write them right there. And more importantly, what we really focus on is the project coordinators create data sheets. And when they do that, they go to, only they can create these data sheets. They go to the place where they can say, I want to measure which organism and what site characteristic and what treatment do I want to measure. So you can bop these down, and kind of like building blocks and Legos, you can kind of build these data sheets, construct them like a house. And so now you've got yourself a data sheet. You go back to your project profile page, and on the project profile page shows up in your data sheets for all your members a data sheet to use to enter data. And all of this, of course, is mobile as well. So then you can manage these members. You might have a pending request. So Allison here, or Amanda, has requested to join this project, and you can approve them, and then Amanda jumps into the members. You can communicate with them. As I mentioned before, you can post resources, post training documents, PDFs, PowerPoints, videos, whatever. And then we came to realize that a lot of these project coordinators may have been doing monitoring for many years. So they might have some Excel spreadsheet. How many people have Excel spreadsheets of data floating around? Everybody's got and then maybe it's on paper, right? It's in some cabinet. I've seen this many times. So people have to take the time to enter all that data. That's another way to crowdsource it. You could use volunteers to do that data entry, which is prone for typos, right? That's why we're doing this mobile technology workshop, is to prevent those typos. But regardless, they might have legacy data. And so in the legacy data, they can upload their spreadsheet, and the system can kind of track and map through semantics what's what, and it'll stick it in the system. I'll talk about that later offline if you have questions. But the upshot is they can upload 1,000 records at a time, and that way they don't have to enter it one by one. We also, in creating our data sheet, realized that some people go out and monitor at the USGS gauging station, or they go out and monitor a nest in their backyard for like Nest Watch. type activities. And then other people opportunistically take observations, right? We have a GPS session, I think, tomorrow. And we'll all learn, or today, I think we have the details of GPS unraveled or something. So anyway, the point is that you can do predefined monitoring locations, or you can do those entered by the user. And so for those entering by the user, you of course need either a device to get that GPS coordinate for you, or something. For those people who are monitoring the same place over and over, they can just use a pick list and say, hey, I went to gauging station 1 today, and the pH of the stream was that. So we've been building support for bulk upload, and we've been building support for predefined monitoring locations. So now we are working on, well, of course, mapping. Everybody's into mapping, and this whole place is filled with map expertise that's probably far surpassing mine. But we certainly have some basic mapping capabilities for the programs to use in viewing their data. And then, much like creating your own custom data sheet, we've got groups that want to create their own custom analyses or reports. So what the system allows them to do, or soon to, actually, this is a coming soon kind of feature, is to say, okay, I want to pick my dependent and independent variables. So I want to look at pH against time. And so in doing so, you construct, much like you construct your own data sheet, you construct your own analysis, and as your volunteers submit data, then all of a sudden you can see a spike in pH because maybe something happened. And so you're like, in real time, what the heck's going on? Why is that changing in that way? So we're pretty excited about some of these support system that we've been working on, and we've got some 66 projects using it, I guess, at this point. Finally, we wanted to give them an opportunity to get feedback from the volunteers, so we built in like a SurveyMonkey kind of thing. And so instead of having to go to surveymonkey.com to create a survey and evaluate their users, they can right here on their project profile page get feedback from the volunteers themselves. And they can construct their own questions and say, do you like chocolate, vanilla, or strawberry, right? Which one? And so maybe the volunteers like chocolate the most, whatever. But hopefully they're asking them something like, what was working for you guys, what wasn't, was the monitoring locations easy to find, or whatever. So, and of course the results come up in real time, and you can kind of see what people are liking. So that's citsci.org in a nutshell. But the motivation of it was to standardize, where appropriate, these different silos of projects. And so if, for example, people are monitoring pikas in the Columbia River Basin, we wanted to say, okay, somebody else might be monitoring pikas, and so let's do it the same. So we came up with this notion of, if you want to measure it, but be sure it's not already being measured. And so it's a little mantra. And we have, so when your project managers are creating these data sheets, they can decide to add an attribute and say, I want to measure the number of black spots on the right wing of this fly, or whatever they want to measure. But what we ask them politely to do is say, look at who's doing what. And if you are wanting to measure something similar, then do it the same way. Because now we're going to get the power of the crowd, as Ian said, involved. And we're going to have a standard protocol we're all following, and that will help us kind of basically allow for data integration to happen much, much easier. So, standardization. For example, you might have measuring life form of plants, and you might call that herbaceous or woody, or someone else might call it grass, forb, or shrub. And maybe we can make sense out of this and agree on a single standard. So that way we make apples and oranges all apples, basically. So now we're going to be talking about technology, and I think I'm going to go through these very briefly because we've got the whole day and all day tomorrow to talk about technology. But obviously we have mobile apps, smartphones. citsci.org is releasing a mobile app sister site, so it's 1,000 apps in one. So these data sheets are created by the managers. We don't know what they're going to create. We don't know what they're going to measure. So what we've been working on, and it's taken us, I think everybody in this room has an app that has beat us to the punch because you guys all built apps before we even got ours out. But we did that for a reason, and that's because our app is trying to interpret what the volunteer coordinator built and say, okay, now show that to the user. So it's like, it's not just an app for a specific topic, if that makes sense. Am I making sense? Kind of? Okay. All right. So anyway, enough about that. We'll learn more about apps throughout the day. But there's more technologies out there, of course. There's wireless network sensors. There's image recognition technology, DNA technology, abiotic water quality monitoring technology, directed discovery approaches, big data. I guess that's versus small, right? Small data. I don't know. But big data is meant to look at meta-analyses and these large data sets like eBird, and I think it's really important to look at that kind of thing. So themes for this for the technologies we'll be talking about throughout the day are efficiency, right? Improve efficiency, improve data quality, and improve synergy. So apps, there's all kinds of apps out there. I've mentioned a few, and you'll hear more today. Sensor networks, there's tons that are already available. You might have streaming data coming in real time, and that can cause problems in and of itself because of the volume and quantity of the data that you might be getting. Image recognition technology, you might be able to identify different species. Hopefully it wouldn't be great if you just take a picture of the plant and we know exactly what it is. But that's going to be challenging, so stay tuned. Water quality monitoring, right, pH devices. You can now plug these things into your iPad and just measure this. There's really cool things coming out. So who knows what that next greatest thing will be. DNA technology is looking promising for species identification, but it's getting cheaper, but it's kind of on the horizon. And directed discovery, virtual field guides, right? You know, dichotomous keys, but image-based dichotomous keys. You can click through and say, I think this is this bumblebee because of the stripes on the wing and that kind of thing. So anyway, tons and tons of stuff going on. What does this yield? This yields data, and it yields data sets. But we would like to think about these data sets as not in silos, but as interoperable data sets, where computer A could make a phone call to computer B and say, give me your stream data, and I want your B data, and is there patterns between, you know, bumblebee diversity and benthic macroinvertebrate diversity, or something like that. So that type of thing can only be accomplished if we have the well-documented data sets, interoperable data sets, open data sets, accessible data sets, and exchangeable data sets. So keep that in mind as we go through the course of the next 2 days. So now we kind of look at solutions. Well, the apps will be one of those solutions. They can help us with data quality. Pick lists can avoid typos. We can get higher accuracy, geospatial locations, and everything's changing. And I think Ian was saying his course changes every year because the technology changes every year. And that's a tough spot to be in, to stay up on all this. But that's why we're all here together talking about it. But what doesn't change is some core principles of really good practices, best practices in building these types of apps using existing and changing technology. So those principles include things like usability, manageability, and interoperability. Those are consistent themes, whether we're talking about a Palm operating system. Remember the Palm pilot? Way back in the day, right? We must have been 5 years, no, not that long, about a year building a Palm app. So we had a mobile technology way back in the day, and it's completely wasted effort, right? I mean, nobody ever uses that operating system anymore. And so now the question then is do these new things we're building, will they be around 10 years from now? I don't know. What's going to be the next thing? Maybe my glasses will have an app inside them. I don't know. But so be wary about that. Technology changes, and you can make a large investment in building a system, and then it gets negated, pretty much. That happened to us. But anyway, so what you can do is keep these kind of things in mind. And you can keep simplicity in mind, and you can have nice linear wizard-based navigations. Obviously, a lot of these you already know, but you can make them fun. You can make them games, right? But they have to be really trustworthy and bomb-proof. They have to be manageable. They have to focus on all facets of the project, not just collecting data. Focus on communicating with each other, people as an important resource, and data as an important resource. How am I doing on time anyway? Okay, that's about perfect. So And then interoperability. How many people know EML, ecological metadata language, or water ML, right? Water metadata language. So these are very technical things. I noticed everybody had an iPad, but not many people know metadata. So that's something we might want to talk about throughout the day. And what metadata does is it's information about information, right? It's data about data. So it tells you that on that day, yes, I saw a fox, but yes, there was lightning coming, and I hightailed it out of there. And that's important contextual information because maybe it was a badger, not a fox, because I was scared because of the lightning. So anyway, metadata is very important. Yeah, obviously, things like datum, what datum was the information collected in. I think we'll hear more about that in our GPS talk. But what was there a transformation, a datum shift, all of this stuff. So interoperability is important. Metadata is important. We've found that a service-based architecture, or API, right, application programming interface, is also a very useful technique for these types of systems to work well together. And the success factors we found is that they're simple and easy. They have a good project champion, somebody who champions the effort and is invested in the effort. And there's an emphasis on high-quality data, appropriate technology. So everybody still had their data sheet. I love that there were so many people that still use pencil and paper too. That's okay. In some cases, that's an all right situation. And then happy volunteers, right? So best practices, make it easy to use and fun, generate high quality data, document and standardize your data, offer many options, many solutions, not just Droid, not just iPad, whatever, iOS, and evaluate and monitor your progress. What are some potential barriers? Well, data quality. Everybody talks about, citizen science data might not be useful because it might not be of high enough quality, but that's what this technology can address. Security permissions, who can do what? Who gets the right permissions to be able to do the work they want to do, and that's sensitive sometimes. Sometimes you have old volunteers. I mean this in the kindest way, but a lot of our volunteers are older generation volunteers, and they're adverse to technology. They look at this and they're like, I am so not doing your project because I don't want to touch that thing. So that's something that's a challenge and a potential barrier. And then the perceived quality of citizen science data. Sometimes scientists look at citizen science data sets and say, not so much, not good enough for me. So there's that perception that it might not be of high enough quality. So what does all this mean? I think I'm kind of coming to my end of my time here today. But how do we know we're making progress? And I kind of came up with this slide that kind of gives us an idea of, okay, if this is today, and we're at 2013, and this is projects domain, maybe plants. This is the green projects, and this project's been going since 2011, but this project's been mapping weeds since 2010. And maybe this is like domain 2, this is like a bird project, and they've been short term, and these guys have been long term, and these guys have been even shorter, and maybe this is streams. So now we've got stream projects, 2 of them. So we've got 3 birds, 2 plants, and 2 streams, and different durations of longevity of these monitoring efforts. And maybe in 2011 they started using an app, but 2010 they had paper data sheets, right? So things change through time. And how do we know we're making headway? How can we say that this new technology has helped us? So maybe you take a snapshot in time and you say at 2013, you measure the impacts of these citizen science projects on science through these different lenses: science, education, society, conservation. And you come up with some sort of metric. Imagine a scorecard. And you say the impacts are really high in education. This is a very highly educational project. So Project Budburst is a plant phenology project, for example, and everybody goes out and measures the timing of when plants change, when leaves wither, and when buds pop, right? At spring, everything's starting to pop. So it's a program, it's a citizen science program that yields high quality data, but its emphasis is on education. It's educating the participants about phenology. So maybe it has a high impact factor on education and less so on science. That's okay, that's its mission. But where are we at today? So then we do some intervention. Maybe we introduce our latest, greatest iPhone app, right? And so now we've got this, and does that help us or does that not? And so then you could reevaluate in 2014 or 2015, of the impact of that intervention, and then keep track of your progress through time with these different assessments. So I wanted to bring that up as one thing to keep in mind. And with that, I'll conclude with the mantra that new and existing technologies will for sure make these types of efforts more efficient and effective. It will streamline monitoring workflows and data life cycles. But where will we apply the technology? Solely at data collection, or will we use it to manage our events, our training events, our scheduling events? What else can it do for us? And so be thinking about that as we go through the day's talks. And with that, I want to extend a great thanks to Brendan and Ian and everybody for inviting me up here and hosting me. And hopefully I've shared a few thoughts about managing citizen science data that might be useful throughout the day. So I think I'll open it up for some questions if you have any.
So,
Yeah,
that.
all kinds of, that's good. I like to see questions. How about up top?
I have a question about the citsci.org.
Yeah.
Do you accept Canadians?
Well, you bet. It's global. Nothing wrong. In fact, we've got some monitoring efforts. I'll be in Ethiopia in June doing some citizen-based monitoring of a very different nature in East Africa, and so it's a global system. Ian, sure.
I was wondering if you've had any experience with government agencies doing citizen science projects and how that works out.
It's an excellent question. In Wisconsin, my wife's from Wisconsin and I'm from Michigan, but the State Department of Natural Resources is heavily embracing citizen science right now. They have a Wisconsin citizen-based monitoring network. And so the state is enlisting citizen groups like Beaver Creek Reserve, for example, a small 200-acre reserve in northern Wisconsin, to monitor lakes, and they'll work with lake associations to measure lake quality and Eurasian water milfoil infestations. And so the agency has developed and is working with us at citsci.org to do a feed to their agency databases. So like through an API, the citizen monitoring data could then go into, and if they want a sandbox first, if they want to vet it themselves, but then use the information for water quality monitoring, lake monitoring. So I'd say in certain cases, states are very excited about this approach. In other cases, not so much. Let's see. Sure.
So citsci, it's an app, not a web interface, is that correct?
It's a little of both. So it started out as a web interface, and at the end of May, short 2 weeks, it will have a Droid and iPhone app that's a sister app that works with the web interface. So it'll have both.
Okay, so what my question is are you able to collect data then when you are not in the cellular network?
Good question. So for that reason, so we've had people use citsci on, myself included, on this phone without the app, and it's been fine, depending on where I am, right? If I have the internet connection, I'm fine. If I don't, I'm not so fine. That's actually the motivation for building the Droid and the iPhone app that we're just about to release. But our challenge, as I mentioned, is that the data sheets created are an unlimited thing that we don't know what people are going to create and what they're going to measure. So the app has to then download. You have to log into the app and say, maybe you're a member of two projects, a BAT project and a stream project. So you log in, and what the app will do, and it's on my phone now, it's not quite tested yet, but we're almost there, is it says, okay, pick your project. So you pick, I'm going to work today, I'm going to do my BAT project. And maybe the coordinator of the BAT project has two data sheets, a level 1 data sheet and a level 2 data sheet. Maybe they're levels of sophistication. And maybe the level 1 data sheet asks you to measure 5 things, and the level 2 asks you to measure 2. So then you pick your data sheet. You do 2 things. You log in, you pick your project, and then you pick your data sheet. What the app then does is it shows those 10 things that the manager has asked you to measure on your device for you to fill out. And since it's a smartphone, it can know where you are, so the location is taken care of course. So we're pretty excited about it, but it's a long time coming. And the reason it's such a long time coming is that we've had to make it 1,000 apps in one, not just dedicated app measuring streams, for example.
But it'll transfer all the predetermined things with that data sheet to your phone, so then when you are not connected to the cellular network, it stores your data.
Yes.
And then you link up.
Very good question.
Yeah.
Sorry, I didn't answer your question, and now I totally understand. So in Utah, in a slot canyon,
Yeah.
you're absolutely getting zero coverage. Yes, you download that, it's an XML file,
Yeah.
and so it saves it on the phone, and so now that configuration of that data sheet is local to the device. So you can enter it, go back to your coffee shop, get connection, and then send your data.
Okay, perfect, thank you.
Sure.
Thank you for your talk, by the way, it's great.
Great.
At the beginning of your talk, you talked about reducing the data silos through the cyber infrastructure, and I can see how SITSI does that. I'm wondering though, are the people that are using it as sort of first-time data collectors, or are they established organizations that are using it as that cyber infrastructure, and then beyond SITSI, is it looking for avenues to send the data that's being collected so that siloing doesn't happen within itself?
Yeah, that's an excellent question. Very, very good question. Multifaceted. I'd say your first part is that we've got groups using it as a first-time data collection effort, and they're kind of new to the scene. We've also got groups that are well-established that are using sitsi.org to use it for data management, and so a little both. But your third question is a really good question, and that's above SITSI, how do data flow from information silo to silo? Because SITSI in and of itself is just a silo. eBird is a good example. Cornell Lab of Ornithology has eBird, and amateur naturalists have been recording birds for a long time on eBird, and it's probably the biggest ornithological data set out there in the world. And so I'm a member of a group called the Data Observation Network for Earth, or Data One group. It's a National Science Foundation group. You can go to data1.org to learn more. And that organization has what they call repositories. It's ecological data repositories, and they tend to be domain specific. But we are working on an API feed that sends data to a Data One repository. So there might be Project Budburst, for example. There would be no reason that a phenology project would want to use sitsi.org because there's already Project Budburst. Nor would an amateur naturalist organization want to use sitsi.org because there's eBird. So what our goal is to not be that single one-size-fits-all, but to do a niche for groups that don't have the resources for development of their own platform, to be a niche for those small bottom-up efforts that need it. But if a large organization would like to use SITSI, they more than willingly can. But what we promised those organizations is that we would share with the Budburst and the eBird through the web service protocols. And so it's a very good question, and people are thinking about that. And the big data can only happen if those bigger silos are talking with each other, if that makes sense.
Yeah, no.
Sure.
For transboundary projects, are you allowed to have multiple managers?
Good question. Excellent, excellent question. And the answer is yes. You can have as many managers as you'd want. And that's not only important for transboundary projects, but also projects with fleeting project coordinators. So a lot of times people move on from job A to job B, and sure enough, they want to pass the baton to another manager in that organization. So the answer is yes. You can have a generic manager, like an email that's an alias, like a, project manager at beavercreek.org, or you could have Joe and Samantha and Bill as well. So yeah, you can have as many managers. And the way that the system works is if someone requests to join your project, maybe you held a training, and maybe you held a training like at the Crown of the Continent kind of thing, in Missoula, but then also here, and maybe you're doing work across the boundary. Maybe you all of the managers, what would happen is both managers would get emails of a request to join a project. So then the managers have to communicate with each other to say who's going to approve that request or not.
Well, I'm gonna
Maybe time for one
take
more?
one more question.
Yeah, okay.
Sure. One of the things about collaborative consumption and your idea of that is this anonymous community. And how do I vet what is good data versus what's not?
Excellent.
And reputations of people and being able to enable people to say, yeah, use this data for this purpose because this person collected it or this group collected it?
Yeah, that's
How
a
do you
yeah. It's an extremely good question as well. We have roles on a project, so there's a manager and a contributor, but I failed to mention two others. There's an expert and an authority. And so those roles allow the manager to change it. So let's say you're a manager and you have a taxonomic expert who's a super volunteer who's really, really good at what they do. You can then change their role to be an expert who can then go vet contributor data, if that makes sense. I think we're running out of time, but thank you. I hope I'm a bit monotone, so I hope I kept you awake, no sleeping. But I think we got coffee coming up soon as well. So thank you, Greg.